Imagine a world where data storage, quick recall, and speedy calculations are a breeze. Welcome to the world of computers. These electronic marvels have nestled comfortably into our society, owing to their three superior advantages over US humans. Firstly, think of computers as your personal library. They can store vast amounts of data, from your favorite songs to the most complex scientific research. This capability is akin to having a warehouse-sized library in your pocket, a feature that is simply beyond human capacity. Secondly, computers have an uncanny knack for recalling information at lightning speed. Picture this. You're trying to remember the name of that catchy song you heard last week. As humans, we might struggle to recall, but for a computer, it's as easy as snapping fingers. They can pull up the data in a fraction of a second, making them the ultimate champions of information recall. Lastly, but certainly not least, computers are math whizzes. They can perform calculations at a staggering speed and with perfect accuracy. Whether it's simple arithmetic or complex algorithms, computers handle these tasks with an ease and precision that leaves us humans in the dust. But despite these advantages, computers have a significant difference from us. We, as humans, are capable of independent thought. We can think, reason, and make decisions based on our experiences, emotions, and intuition. On the other hand, computers are dependent on the instructions given to them. They don't think or make decisions on their own. Instead, they follow a set of pre-programmed instructions to perform tasks. In a nutshell, computers are our partners in processing information quickly, accurately, and on a large scale. While they may not possess the ability to think independently like us, their superior data handling capabilities make them indispensable tools in our modern world. Stay tuned as we delve deeper into the fascinating universe of computers and programming in our upcoming scenes. From decoding programming to understanding pseudocode, we've got a thrilling journey ahead, so don't go anywhere. This ride is just getting started. Now, have you ever wondered how computers understand us? Enter the world of programming. This is the process that breathes life into our machines, turning a mass of metal and wires into a responsive, helpful tool. Programming is the art and science of translating our human thoughts and commands into a language that computers can understand. It's like being a bilingual diplomat, facilitating a conversation between humans and computers. The purpose of programming? Well, it's to make computers do exactly what we want, whether it's launching a spaceship or playing a catchy tune. The role of programming is vast, extending from the software in your smartphone to the systems controlling global financial markets. So when you type a website URL into your browser bar, or when you swipe right on your favorite dating app, remember, there's a symphony of programming at work beneath the surface. Programming, in essence, is telling a computer what you want it to do. So, is programming the same as coding? Not quite. Let's break it down. Coding is like writing a recipe. It's the act of translating one language into another. Coders take the design and instructions given to them by programmers and turn them into a language computers can understand. On the other hand, programming is a bit more comprehensive. It's like being the chef. Programmers not only write the code, but they also create and design the software. They solve problems, create algorithms, and structure the entire project. It's like constructing a building. Coders lay the bricks, while programmers are the architects, designing the blueprint and overseeing the whole project. So, while coding is a part of programming, programming involves a higher level of abstraction and complexity. It's a strategic process that requires problem-solving skills and a deep understanding of algorithms and data structures. While all programmers can code, not all coders can program. Let's dive into the language computers speak. Just as we use languages like English, Spanish, or Mandarin to communicate with each other, we use programming languages to communicate with computers. Languages like Python, Java, C++, and many others are our tools, our paintbrushes, to create the digital world. These languages are built on binary code, the most fundamental language of computers, made up of ones and zeros. This binary code is what a computer truly understands, but it's not very human-friendly, is it? That's where programming languages come in. They act as a translator between our human-readable code and the computer's binary language. Each programming language has its own syntax, rules, and structure, which is why learning a new one can be like learning a foreign language. But don't worry, with time and practice, it becomes second nature. These languages are our bridge to communicate with computers. Developing a program is like constructing a building. It has stages. Just as an architect drafts a blueprint before laying the first brick, a programmer too outlines a plan before writing the first line of code. This plan is known as program development, and it follows a series of stages to ensure the final product is both functional and efficient. The first stage is problem identification, which is essentially understanding what the program is meant to achieve. It's about identifying the issue that the software will solve. Following that, we have the planning stage. Here, the programmer devises a strategy to tackle the problem identified. This could involve brainstorming, creating algorithms, and even sketching flowcharts to visualize the solution. Next comes the coding stage, the point where the programmer starts to write the software using a specific programming language. This is where the plan is put into action, and the program begins to take shape. After coding, it's time for testing. This is where we check if the program works as expected. The programmer runs the software, looking for any errors or bugs that might affect its functionality. If any are found, they are fixed, and the program is tested again. This process continues until the program is error-free. Then we have the documentation stage. This involves creating manuals and guides to help users understand how to use the software. It also aids other programmers in understanding how the software works if they need to update or modify it in the future. Finally, we have the maintenance stage. This is an ongoing process where the software is updated and improved upon to meet the changing needs of its users. Throughout these stages, programmers use tools like pseudocode, flowcharts, and hierarchy charts to simplify complex processes and visualize the program's structure. Pseudocode, for instance, is a plain English version of the program's code, making it easier for non-programmers to understand. Each stage of development is a stepping stone towards a functional and efficient program. So, just like constructing a building, developing a program requires careful planning, execution, and maintenance to ensure it serves its purpose effectively. Now that we have our tools, let's look at the blueprint of a program. Every program, like a well-structured story, has a start, data declarations, data input, data manipulation, information output, and an exit. Starting a program is like opening a book. It's the point where the magic begins. This is usually where we initialize our variables or set the stage for the rest of the program. Data declarations are akin to introducing characters in a story. This is the stage where we define the variables that we will use throughout our program. Just as characters have names and attributes, variables have names and values. Data input is like setting the scene. It's where we get information from the user or another source. This could be anything from a user's age to the current temperature. Data manipulation is the climax of our story. It's where all the action happens. The data we've collected is processed, transformed, and manipulated to achieve our program's objectives. Information output is the resolution of our tale. It's where we present the results of our data manipulation to the user. This could be in the form of a message on the screen, a file saved on a computer, or information sent to another program. And finally, the exit is the closing of our book. It signifies the end of the program, ensuring all processes are wrapped up neatly and resources are freed up. Now, let's talk about pseudocode. Think of pseudocode as the rough draft of our story. It's a simple way of outlining a program before writing the actual code. It uses plain English to describe what the program does, step by step, following the structure we've just outlined. Pseudocode isn't bound by the rules of any specific programming language. It's a tool for planning and communicating the logic of our program. Just like a rough draft, it helps us organize our thoughts and refine our plan before we dive into writing the final code. Just like a story, every program has a beginning, a middle, and an end, and pseudocode is our rough draft. Let's take a moment to reflect on what we've learned. We started by appreciating the superior data storage, recall, and calculation capabilities of computers. We then unraveled the mystery of programming, the process of instructing a computer to perform a task. We distinguished programming from coding, the act of writing the instructions in a specific programming language. We delved into the language of computers, which is binary, and how we, humans, communicate with computers using higher-level languages. We journeyed through the stages of program development, from defining the problem, planning the solution, coding the program, testing it, and finally, maintaining it. We identified tools like pseudocode, flowcharts, and hierarchy charts that help design programs, and discussed the program structure, including the start, data declarations, data input, data manipulation, information output, and exit. We even touched upon how pseudocode uses this structure. Understanding these basics is your first step into the fascinating world of programming. So, are you ready to speak computer?